let's look at this force. The forces shown are the resultant downward load on sections of the flat roof. So this is the flat roof, and these are loads. 1, 2, 3, 4. 4 loads. Flat roof of a building because of accumulated snow. So there's a snow accumulation, and there is 4 loads of snow accumulation. Of course, snow will have force that will affect the roof. Determine the magnitude and the point of application of the resultant of these 4 loads. He wants to know where is the resultant, the magnitude, and the point of application. Okay, so let's make this one bigger. And let's see. Now, you can see that there is a 116 kip, and there's 28 kip, 470 kip, and 66 kip. Now, how could you find the resultant? You can see that all of them are going in the negative y. So, if you do summation of forces of all these forces, you're going to see summation of forces equal minus 116 kip J, minus 28 kip J, minus 470 kip J, and minus 66 kip J. So you do them like this. Summation of forces, you put them all in the minus because they are all in the y-axis. You just put them all and you subtract them all from each other. You will end up with an answer minus 680 kip J. So this is the resultant. So the resultant force of all the forces is minus 680 kip J. Later on, now we want to find out the location. Where is the location? So let's look at the z-axis. So we should find out the location of this resultant on the z-axis. Now, remember, it's 680, that's a total, times the location z. The location z, okay, equal the first one. Let's see the first one, 116. What is the location of 116 from the x-axis? Okay, from the, of course this is in the z direction, but from the x-axis you can see it's 24. So you can see that the resultant 680 times the z, that's the location on the z-axis, 116 times 24. That is from the x-axis, because you can see that here there is x and there is z. So you are going in the z direction toward the x. So it's 24 feet toward the x. You can see 24 feet toward the x. So this is 116 times 24. Let's go for the 470. Where's the 470? It's here. What is the distance? Of course, in the z-axis toward the x-axis. So you can see that this is the direction, and you can see this and this. 30 plus 18, that's 48. So 470 times 48. Now let's go to the next one, 66. 66 is this one. In the z-axis, this is the z-axis toward the x. That's 18. So 66 times 18. 66 times 18. The last one, 28. In the z-axis toward the x-axis, that's 18 and 30, 48, 52.5, which is equal to 100.5. If you sum up all these numbers, this is the distance on the z-axis toward the x. So we're going to do it as 28 times 100.5. So you do this calculation and you find the answer for z and this is the point of application of resultant loads along the z-axis, 43.156. Okay, now we found this. Now let's find the line on the x-axis toward the z, and we call this other point of application. It's along the x-axis. Okay, first of all, 680 times x, it's along the x-axis. 680 times x, it's the same resultant. Let's do the first one, 116. 116. Now it's not along the z, it's along the x toward the z. So this is 30 feet. You can see 30 feet. Okay, so we do it like this. 116 times 30 feet plus 470. Let's go for 470. Now we are doing along the x. 470. Oh. .470 along the x toward the z. It is 96 feet. So this is 96 feet plus 66. Let's go to 66 here toward the z along the x-axis. 66 and 96. Let's just go 60 and 90. That's 150. 150 and 12. That's 162. So it's 162. The last one, 28. 28, where is 28? 28 is that way. You have to go to in the x-axis toward the z-axis. You can see it like this. This is 96 feet. So 96 feet. You rearrange the equation and find the x. X would be equal 91.147. This is the point of application of the resultant loads along the x-axis. Now we found the resultant, and the resultant is going to be with the value of 680 kibs, and the resultant in the x-axis is 91.147, on the z-axis .156. Okay, thank you.